Okay, guys, so let's go ahead and talk about the ocean floors. We've been studying the plate tectonics and these kind of things. Let's look at how the bottom of the ocean floor is affected by these things and what we can expect to find there and how it's used by man, actually. All right, so as we look at our world, 71% of the Earth's surface is represented by the ocean or marginal seas. So that's pretty much underwater for the most part. Continents and islands is about 29%. So you can see that our world is really a water world with 71% of it being covered in water. When we look at the globe from the top, we call it the land hemisphere. And we look at it from the bottom, it becomes the southern hemisphere or the water hemisphere. You can see in this picture that if I look down on the globe from the top, you see most of the land is in the northern hemisphere. Now, it hasn't always been this way. In the past, it was exactly opposite. But through time and plate tectonics, things have moved. If we look at the southern hemisphere, you can see how this is mostly ocean. This water around in this area, especially in the straits right here, become very violent because as they are able to swirl around and storms come through, this part of the world is very rough on shipping, and mainly because there's nothing stopping the water. See, there's no real land masses to slow it down at all. So it becomes not only cold, but really windy and really rough weather in the bottom of the ocean. And it's mostly water. All right, so in the Pacific is our largest open ocean. It's also the deepest. When we talk about the Atlantic, it's about half the size of the Pacific and really isn't as deep. So we've actually studied the Atlantic quite a bit more just because it's more shallow and we're able to do that. The Indian Ocean, of course, is a little bit smaller than the Atlantic. It's the biggest in the southern hemisphere, however. And then, of course, the Arctic is about 7% of the size of the Pacific. So you can see how large the Pacific really is if you think about a map and how big those ocean bodies are, or these basins in this case. Take a look at it. You can see the Arctic is at the top. This is the Atlantic, of course, the Indian and the Pacific. Now, this is the bottom that I was talking about, where how water can just keep swirling. You see, everywhere else, land breaks it up, but that doesn't happen. So water can go from the Pacific to the Atlantic to the Indian and just keep swirling around Antarctica like that. So that's where this weather is so rough down there. All right, we're going to be studying right now is something called bathymetry. Bathymetry is really what it comes down to is the measurement of the ocean depths. And in order to measure those ocean depths, we're able to make a chart or a topographical map because of it. You're actually going to get a chance to do that. Now, with echo sonar is what we use to really help us. This was invented in the 1920s and is a primary instrument for measuring depth, and it still is today. What it does is it sends a sound wave down to the bottom and it reflects it back. What we do is we take the amount of time and we measure how long it takes if we know how fast a sonar or a sound wave will travel through water, salt water in this case. We go down, it bounces off the ocean, comes back up. We can measure in that little spot how long it took, and we know how deep it is from there. You can see how the signals go down and then right back up. I use this very same technology in my boat when I use my fish finder. So this technology has come a long ways and is really well used. Now when we map the ocean, we use a little bit stronger sonar called a multi-beam sonar because it gives us a little bit stronger source and we're able to get a little more detail out of it. And it can actually help us obtain a profile from a narrow strip. If we look at this one, you can see rather than the waves going down, this is also waves, but it goes down and rebounds in that reflected area. So it's more like a swath and it reads across. Something like we would use in our satellites when we want to take a look at a different planet. Now, this is how Mars was measured. Well, it was with this same multi-beam sonar from a satellite, of course. But that technology came from these ships doing this, mapping the sea floor on the oceans. All right, whenever we map the ocean floor, we have three major topographical units in the ocean floor. We have continental margins, we have ocean basin floors, and mid-ocean ridges. This is what we're really looking at when we're mapping the bottom of the ocean. They're the major topographical features that we see in the bottom of the ocean. So for an example, if I was to measure the Atlantic Ocean, you can see where I would start in North America, say right about New York, and we'd go straight as we could across the ocean, measuring the depths all the way across on one single line to Africa. Now you can see that this line, this is the continental shelf, and as soon as we come off that shelf, it really drops off deep. It gets pretty deep until it comes more shallow in the center, and then it drops deep again and shallow towards the continents again. If we look at this bottom down here at the bottom, you can see there's the continental margin that drops off, gets deep, gets a little more shallow towards the mid-Atlantic ridge, and then deep again and back up. So you can see it's kind of like a W, if you will, on the bottom of the Atlantic. And this is what that side view of that same straight line would look like as I go across the ocean with my ship. Now, some of the other continental margin marine provinces that we'll see and we measure are passive continental margins. These are found along coastal areas and surrounds the Atlantic. So if you think about a lake and it has a little beach on the side, this is kind of what we're talking about, only in the ocean now. It's not associated with plate boundaries, whatever. This usually has to do with erosion from the continents and pushing it back into the ocean, the sands, and so forth. And this area experiences very little volcanism, and there's very few earthquakes. So it's just really part of the continent. It's a continental shelf there, and we don't experience those things. Passive continental margin, the features are compromised of the passive continental. This is the continental shelf. It's a flooded extension of the continent, so it's still part of the continent. So it's still part of the continent, but it's underwater normally. It varies greatly in width, how deep it is, how far it goes out from the continent. It's usually gently sloping and will typically contain oil and important mineral deposits. And that's going to be important in part 2 of this unit, because we're going to actually look at drilling and how we mine for oil and gas in, say, the Gulf, and how that happens. Some of the other passive features, the features are compromised with passive. You'll see here that most consist of thick accumulations of shallow water, and there's also lots of sediments, and that's mostly because it's been washing off of the continent, and then it makes these beaches that we are like a beach, but it's more of a basin off of there. You see there's some more things that we also see in this area. They're relatively deep structures. The boundary between the continental crust and the oceanic crust. If we look at different types of crusts in the globe, we have continental crusts and we have oceanic crusts, and this is typically where these two will meet. Even though we don't see a lot of activity volcanically or even geologically speaking at this area, this is where they do meet up. This is an example of a continental margin. So if you think about this as being the United States, and we come off of the continent, we end up in these little shallow shelves, and then of course the shelf breaks off at some point and slopes down. This is mostly eroded material that came off the continent over millions of years, and just like a little shelf off. So I mean, if you've ever been to a beach, you know how it gradually gets deeper. But that's exactly what we're talking about here, until it gets to the very bottom, which can be actually abysmal at the bottom. Here's an example of one of these regions. You can see the clay and the mud, the different sedimentary layers over millions of years. This is happening. This is an example in Maine of how this works. Okay, we take a closer look. You can see the sediment. There's actually fossils located in there. You can kind of get a reference for the size of these with the quarter sitting right there. Here's another example. This is California. It goes off and drops hard, but the sedimentary that marginal shelf starts out there and starts to go as below these rocks because they've eroded off from the waves and the crashing in. All right, so that's it. There's a couple assignments to go with this, and they're going to actually do some mapping. Let's check it out and see how we can get this taken care of.